Here we're going to look at some more evaluations, but this one's a very specific and important evaluation. It's known as the difference quotient. It is used a lot in calculus when you talk about a derivative. Now, the difference quotient is just the slope formula in function notation. So this, remember how we said function notation, f of x is y. It's just a different way of writing the y value. It's pretty nice because when we solve for the y value, we would plug in our x, and then we would have our y. But the nice thing about this function notation is that you get to visually always see the x that was plugged in, and then you also find your y value, which is really nice because you can keep track of x and y. And so this is talking about the change in y's. So again, the x plus h is just talking about a different y, and this is your first y. So from a different ordered pair. So this is just the change in y's. And this h represents the change in your x. So to kind of emphasize that this is a different x coordinate than this one, is just saying plus h, that distance between this second x. And it's represented with this h. But here we're just going to practice evaluating it. So it's like a double evaluation because we have to find this x plus h part, similar to what we did with like this x plus 2, or we did an 8 plus h. Same exact idea. It's just going to be x plus h. But then we have to plug into the difference quotient. So there's finding this value and then substituting in. Now, to substitute into this f of x, we already know that. So we could almost right away just plug this in. But to save some space, I'm going to find this portion first. So this is going to be your f of x plus h. And since I'm going to plug in something large, I'm going to make room to plug it in. And I don't know if you notice, but this is very similar. So we're looking at 3x squared plus x. It's the same one as this 3x squared plus x. So this all simplifies to this one right here. The only difference is instead of the a being a, all those a's are going to be x's. So for the sake of time, I'm just going to copy all this. You will refer back to the previous video. This is what it's going to become, but I'm just going to replace all the a's with x's. So x, x, and x. And that's this top part of the difference quotient. So I'll be able to make that substitution. I'm already just going to make this big parentheses to make it fit. Minus, and then I now have to plug in f of x. And this is all over h. So I'm just going to copy this. I'm just substituting it. Just make it a little smaller. Then I'm just going to copy my f of x. And that's the difference quotient. Right? You can see it right here. I'm just replacing f of x. We found it. It goes in here. Our f of x goes on this side. And now we just have to do a lot of little algebra. meaning this negative has to distribute. Sorry. That's going to be minus. This is going to turn to a negative. And if you notice, these two are exactly the same. So they are going to cancel out. There's also this x here. X and this x. One's positive, one's negative. That means they're going to cancel out. And we're going to be left with that 6x h plus 3h squared plus h all over h. And the next step is not obvious, but something to keep in mind. Whenever you look at multiple terms that have the same factor, don't forget that you can factor it out like a GCF, if you guys remember doing your GCF factoring. You can take out an h. So this has an h. So factors are separated by multiplication symbols. Terms are separated by plus or minus signs. So because of this h, there's two h. This h times h, right? And this is h. They all have at least one h in them, and that's this h that I have here. You can always distribute back, multiply through, and you'll be able to go back to your previous step. Now, you have to be careful because this last one, a common error that's made is that because the only factor in this term is h, sometimes we tend to completely forget about it. But just because you factored out that h, there's still this lingering one left. Because the problem is, if this wasn't here, if I go back to try to distribute, I wouldn't get back this expression. So that 1 is to multiply to get back this term. So it's always important, just because you factor everything out of that term, there's always still that factor of 1 remaining. And we do that because we have an h in the denominator, and this allows you to simplify them. And I'm left with 6x plus 3h plus 1. And remember what I said, the difference quotient is a formula, was the slope formula. So this, once you get to calculus, is the slope formula for something known as a tangent line, which will later in your calculus be defined as your derivative. And it's really just a slope formula. It lets you find the slopes of these lines that are along a curve. So let's say you're thinking about this curve. A tangent line is one that just intersects your graph at one point, and it makes this line, right? And that's where, I don't know if you've ever heard people say that you go off on a tangent. It's this idea of that here's your conversation, right? This is the path of your conversation. And at one particular location, someone just goes off on a tangent, right? It just goes in a completely, but the idea of a tangent is you intersect at one point and then it just continues going. But this is a line, and this has a slope to it. And this formula helps you find the slope of this line. And it helps you to find any tangent line. Like this is a tangent line, that's a tangent line, here's a tangent line, here's another tangent line. It can help you find the slope of any of those tangent lines. If you continue to calculus, that's what this is used for. But let's keep going. Do a couple more examples. So here we have 1 over 2x, which I believe, I could be mistaken, that we did not write with it. That's fine. Here we go. Now, like I said, we have to find that x, but in this case, it's h of x plus h first before I substitute into my difference quotient. And because I know I'm substituting something larger, I do like to make my parentheses bigger and put x plus h. But this one's much nicer than the previous one because all you're going to do is distribute 2 into both of these. That's going to leave you with 2x plus 2h. And now I have my difference quotient that I can substitute into. I'm just going to write it a little differently just because this is h instead of f. So I'm going to write h of x plus h minus h of x all over h. And I'm going to substitute, this is x plus h, this is x plus h. I'm substituting with what we evaluated with. So that's going to be 1 over 2x plus 2h minus, and then just whatever h of x is, which is this 1 over 2x. 1 over 2x all over h. Now, when you're adding fractions, you need to have the same denominator. And I know it's the first thing that maybe we see is, oh, all I need is a plus 2. But just adding plus 2h does not keep, like the idea is this has some value to it. We always have to maintain its original value. You can't just add 2 plus h just because that would make things easier. The only way to keep the original value and to add this factor, I know it looks like, oh, it's just 2x plus h, but no, this whole denominator, it's its own factor. It's made up of two terms, but it's its own value. The same way 2x is going to be its own value. If we were to actually plug numbers into these variables, the whole denominator will change and they will not be the same. But to be able to add fractions, you need the same denominator. So what you can do, luckily we have something known as the multiplicative identity, right? And the multiplicative identity is just a number that you can multiply it to any value and it does not change it. And that multiplicative identity is the number 1. Number 1, you can multiply to anything and it does not change the value. But we can make 1 look however we want, as long as we are dividing two identical values. So what I mean by that, I'm going to divide by, well, multiply by 2x plus h because that's the denominator that first term has. But I'm going to do this to both the numerator and denominator. Ooh, I forgot the 2h. Now, when you divide two things that are exactly the same, this is actually 1. So I'm multiplying by the multiplicative identity. But then this side has its own factor of 2x plus h, but it needs a factor of 2x. Now they will have the same denominator. So that will be, and the purpose of getting the same denominator is so that you can combine everything into one single fraction. So I will have to distribute this negative pertains to this 1. I will have to distribute it through. And then 1 times 2x. That's going to give me 2x minus 2x minus 2h all over 2x plus 2h times 2x. And this is, I'm going to put it big bold. This is my original fraction over h. Now in the numerator of the numerator, those two x's can cancel out. And when you divide with fractions, you have to remember that you have to multiply by the reciprocal of the denominator. Right now, we might not see the reciprocal, but remember, this is like saying h over 1. So this is going to become just negative 2h all over 2x plus 2h times 2x is all the denominator times 1 over h. And here you can simplify, and that's the main goal right now for us, is just to simplify that h if possible. At least one of them. Obviously we can't simplify that h inside, but that's going to leave us with negative 2 all over 2, I'll write 2x first, times 2x plus 2h. Now there's also something known as the commutative property of multiplication, which says a times b is the same thing as b times a, which is what I'm applying here, right? I had the 2x, so think about this as a, and then this is b, and then I put b times a. You can commute them with each other. If you want to try any of these examples, again, pause the video at any moment and try to find them. But let's keep going along here. Now this one's going to be a little bit bigger, but it's a fraction, so it has a very similar concept as the last one. So I'm going to find my h plus x first. But if you notice, I like to write my parentheses so that when I input the x plus h, no errors, right? No silly mistakes to make. I just have to input, make sure I copy everything correctly. Luckily, this one's even quicker than the last one, because there's nothing I can do with this parentheses and this minus. It's just going to be 1 over x plus h minus 3. Now the challenging part is going to be once we get to the actual difference quotient, which now it's going to be g of x plus h minus g of x all over h. But luckily we have our, it's just right here. I'm just going to copy and bring it down. Sorry. Minus, and then my g of x, I'm just going to copy it. So you can see I'm literally just taking g of x and I'm substituting it. Because g of x is here, this is g of x, so is this. This is x plus h, this is x plus h, that's what it simplifies to. And this is all over, this is all over h. Now, same thing as before. I know it seems that, oh, x, and there's a minus 3 here. All we need is to add h. Once again, you can't do that, because you're going to change the ratio of this number. The only way to manipulate it is by multiplying by 1. We just have to make 1 look like a different value. So that's going to be x plus h minus 3 over x plus h minus 3. And then this other one, oops, we need to multiply by x minus 3, x minus 3, and now we try to simplify all of this. So it's going to be x minus 3 all over x plus h minus 3 times x minus 3 is the denominator, minus this negative is going to eventually distribute, but it's just all x plus h in the numerator, x minus 3 times x plus h minus 3. And I know these are swapped. Look, x plus h minus 3, x minus 3, x minus 3 times x plus h minus 3. Remember, this is like saying a, b, b, a, right? A times b is the same thing as b times a. So they are the same. and all over h. And once the goal of having the same denominator is to combine everything into one single fraction. And once you have into one single fraction, you can continue simplifying. But you have to remember, this negative is going to distribute to that numerator. So that's going to be x minus 3 minus x minus h. But that last 3 is going to become positive because a negative times a negative is positive all over. And I'm just going to write x minus 3, x plus h minus 3. You have to just pick one. Either write it in this format or that format. But they are the same because of the commutative property of multiplication. Now again, this is all over. This is all still over h. But in the numerator, the x is going to cancel and the 3's are going to cancel. And we're going to do the same step as before. This h is like h over 1, and we're just going to multiply it by the reciprocal. So all that's left in the numerator is negative h over x minus 3, x plus h minus 3 times 1 over h. The h is simplify, and you're left with 1 over negative 1, right? Because there's still that negative there, of x minus 3 times x plus h minus 3. And that's the difference quotient for that one. And we have a couple more to try. This one's very similar to this first one. So let's go through this again. R of x plus h. Like I said, I like writing my parentheses a little bit bigger. I know x plus h is going to go in here. But remember, this part of x plus h, this x plus h is, this x plus h squared means x plus h times x plus h. And then once you distribute all of this, it's x squared plus xh, and then plus hx plus h squared, which remember, xh and h squared are the same. So that's going to be 2 times x squared plus 2xh, and a commutative property of multiplication, plus h squared and minus 4. So I like to do that on the side just so I don't mix it up. I can distribute this 2. That's going to be 2x squared plus 4xh plus 2h squared minus 4. And that's going to be my x plus h and minus rx all over h. But I'm just going to substitute it. It's going to go in here. I'm going to copy, paste. Oops. I made it too small. It's going to go here. Minus 2x squared minus 4 all over h. You're going to distribute this negative through. That's going to become negative. That's going to become positive. 2x squareds are going to cancel. The 4 part's going to cancel. And you're going to be left with 4xh plus 2h squared all over h. And once again, you can factor out the h. The h is simplified, and you're left with 4x plus 2h. I'm going to do this next one for the next video, but before I do that, I'm gonna talk about radicals. But try to go through these, see how, and any time in the video, you can retry them again and see how it goes.